Hello people, I'm gonna resume the streams right now. Here we go, that should be good. I hope the volume is just fine too. It should be alright. I'm a bit tired, it's already like almost midnight, but that's fine. Let me quickly just listen to my own voice because I like it so much. Please, okay? Okay. Please load. 3, 2, 1. Okay. Let me quickly just listen to... Yeah, this is beautiful. What a beautiful voice. Let's keep it like that. And... Hello people! Hello! Oop, I don't need that. Okay, here we go. So, let's see what we had last time. Da-da-da-da, we basically had this. So we have some snow, right? We have some grass, so we have some biomes, as you can see. We also have some caves that look a bit weird there, but let's go there, for example, and it's a bit better. It's not really caves, but it's not really a cave, but that's fine. It looks fine. It looks neat, kind of. Could be better, but yeah, I mean, there's like some things I have to handle, I suppose, but it looks alright. It doesn't look very natural because there is like, it's like flat, well, almost flat over here, but it's actually not flat, but yeah. So yeah, I was thinking one of the things we actually need a lot is ambient occlusion, but because it's like a bit hard to see the blocks, to like differentiate them, but that's fine. And what we are going to do instead, in the meantime, well, before that, I mean, is custom collisions. I want custom collisions. And I actually started something on my side. This. Well, I created a lot of classes that I'm never going to use. But basically I was thinking that my architecture was... Well, it kind of sucked, honestly. Because it wasn't made to be thread safe. There wasn't like a separation between the interface and like the, how it was actually implemented, that kind of stuff, right? And I was kind of curious about, well, not really curious, but I was thinking of maybe doing something like the rendering server of Godot, which has, well, which splits the implementation from our IDs, right? From the handlers. And I was thinking about doing something like that because we are going to use a lot of threads, and I'm actually not sure. Well, there are going to be problems multi-threading wise, but anyways, and another reason I want to make those singletons, because they're singletons, is for collisions, I want to be able to manage multiple... let me just reduce a little bit. I want to be able to do the collisions between multiple spaces, right? So yeah, I would say that's it. 2 seconds. Okay. So I'm actually not going to care about any of that. I'm just going to care about one thing, and this is collisions. collisions. What was it? Collision server or something like that. Do I have that? Collision server. Wait. Voxel physics server. Why even is that? Voxel collisions. Oh, right, it's a new one. It's this one. Okay, so we have a singleton. That's actually not a singleton yet. We have to finish it. But then we are going to implement all of our optimizations and stuff over there, in there. And I guess I also want... I guess I want a bunch of things, okay. I want a bunch of things. So, I was also thinking about splitting like cube voxels from not cube voxels, because I don't really want inheritances if I can, but at the same time it saves us like just so much code duplication that it's nice. And otherwise what I could do is I could make templates, but I'm, you know, actually no. I was gonna say there's like compile time. Well, by default templates increase compile time, but I guess you can always instantiate them in a C++ file to make it a bit faster. And well, instantiate the templates. Yeah, how do you call that? I forgot. But instantiate a specialization, you could say. And another solution would be to use function pointers, which I'm not really a fan of, because if you use function pointers, you know, you can just hold functions instead. That's kind of the point. But yeah. So physics server, we have this. Then you go back to here because I actually started making some implementation. Boom. Boom. Just gonna copy everything. Voxel collision. Voxel physics server. Here we go. Boom. And we remove this. Okay, I forgot what was missing. I think it's like in register types. You have to register the singleton. So something like, I guess I made it kind of bad, but let's include this. Wow. Voxel collisions. Physics server. Here we go. And make, or like create singleton. Yeah. Create. And wait, is it there? Okay, I guess it's there. I mean, I guess I'm implementing my singletons in different ways, but that's fine. Wait, should I do that? At the end, we have the remove singleton. Yeah, I really don't need this to be here, do I? Why do I have this here? I don't know. That's fine. A non-static member reference must be something. Huh? Oh. Oh, my bad. Get singleton. Okay, I guess I don't have it. I actually wanted this to be... Never mind. What am I doing? I don't know. Maybe just or not. I mean, I guess I can just meme you. That's not a big deal. And we have Voxel Physics server. And I suppose that's it. And that should be good, right? Am I missing something? Let me check out Voxel DB. But I think that's it. Oh, I have to inherit object. Am I inheriting object? Yeah, I am. Get singleton. Yeah, I'm gonna copy this. And I guess I have to destroy it at one point though. Like there. Boom. Pointers erase. Yeah, I think I have to delete the pointer to prevent leaks. But I'm not gonna do that because I'm a bit dirty. So we're gonna keep things like this for now. And because I want to focus on what actually matters. So physics server, what are we going to have? We are going to have, do we want a step? What do we want? I guess we're going to have different spaces that are going to be simulated. So this is the first time we are actually going to have like different spaces, really. So I'm not sure how it's going to turn out, but wait. Yeah. Okay, for now let's just have local vector. It's not T because T is for Unreal. It's like templated types in Unreal. So we are going to have chunk space like this. And then maybe we want an update. Is it going to be on its own thread? That's the question. Because I mean, I guess it's going to read a lot of voxels, but well, actually sometimes it might modify them, but yeah. I guess I actually made a document last time about this, right? So voxel collision. Here it is. And I said that my priorities are moving the player and make them collide with the world. Okay, so player. And basically I guess I won't do that because I'm gonna have to do that anyways, right? So I'm gonna implement that for the player first to see if it works well. And if it works well, then we can, continue, and, optimization comes next. Okay. So the separating axis theorem. Something. So we have all of that. I mean, again, I want to split. I want to specialize it for cube chunk space, but yeah. I'm not sure about that. I mean, it can be fine. Chunk space. What if I have, instead of chunk space, I'm probably going to have some other class like chunk space collider, something like that again, because I have another class with the same name, I think. But voxel collisions. I don't know. Wait, it's like in... Was it in a namespace or something? Maybe I can just put it in a namespace. Yeah, maybe that's gonna be fine. And this is gonna be... Whoa. This is gonna be voxel physics, maybe? Yeah, here we go. I wanted the comment. So, voxel physics. Chunk space collider. So what is this one going to have? It's a space. And for colliders, we want it to... This is very important. We want it to have... Oh. A vector. Do I want... Do I want an index to a big array, or do I want to... Do I want it to have its own vector? Let me just think about it like 2 seconds. I mean, okay, never mind. I did think about it for 2 seconds, and I suppose it's fine. It's going to be a vec3, which are going to be the axes, like the normals, I guess. So we have a collection of that, space colliders, and I guess I want to cache the normals. Well, cache them, I suppose. And I also want... Oh, but... Does it make sense then? Maybe I want something in this class instead. Basically what I want is I also want to store the cross products. But for that I need like a hash map or something, or like a map. A hash map maybe, that maps a pair of space colliders to the cross products. I don't like hash maps. It feels slow. I know it's supposed to be O1, but for me it's in directions, right? Like you have pointer in direction. So let me think about it. Can I make it better? I could make a table, technically, right? Because I'm always going to test only 2 spaces against each other at a time. So boop, boop. I can also divide it in 2. And... yeah, but what if I remove a space out of nowhere? You know what, I'm just going to have this. And can I have maybe key, maybe not key value, but a pair. And it's gonna be a pair of that and that. Maybe I want to struct instead. And then the value is going to be collision cache maybe. Like chunk space collider collision cache. Oh, not this cache. This cache. Something like that. Containers. That core. Templates. A hash map. Here we go. I'm starting to remember. So declaration does not declare anything, does it? What about pair? Templates. Core templates pair, yeah. Is it good? No, it's not. Oh, okay. Is it good now? Well, actually, I already have this here, right? So I don't really need that. Oh, okay. No, I need a name. Here we go. Here we go. So we have this, and then we have normals, cross products, basically. But yeah, it feels like it's going to be a bit bad, like that. But like the cache is not going to be very contiguous, right? Like I'm going to have a lot of hopes and stuff. So maybe a single vector. And I want indices. Maybe that's for the best. So I'm gonna have normals. Like space normals. Then I'm going to have, and I'm gonna allocate in there basically. And then I'm going to have space cross normals. Actually, never mind. Space normals, like SAT axis. Okay. That sounds alright. Does it? It feels like I'm going to have holes if I do that. Maybe it's fine. Maybe not. Because I'm still going to have to move the normals if I remove a space. But I'm not going to remove... Okay, maybe I'm going to remove spaces out of nowhere. I don't know. Okay, let's keep it like this for now. Okay. So I'm going to have something like axis start index. Yeah, I must want to put like -1, but let's go with 0. Chunk space collider collision cache. Maybe pair. Something like that. So let's say we have this. Let's say we have the pairs. Okay. I'm gonna have the same. Is it actually the right thing to do? Now that I think about it, do I actually need all of this? I mean, I suppose. Okay, let's keep it like that. And so we have the pair. We can get the data. Can we? Okay, let's say we can. And it's like chunk pair to chunk pairs. Number one fan. Hey, welcome back. Welcome back, welcome back. This time we're going to implement our own collisions. Like we're going to do some math, I suppose. But that's fine, it's not that complicated. I was just thinking about, should I have a step or something like that? And what was it? So step, I mean, maybe a step is fine. At least a step. Because I also want to resolve, right? So for now, let's just have this. Let's just have the using namespace. That's fine, because we're in the C++. Using namespace, right? We have this, and the algorithm is going to be pretty simple. Is it? Actually, we want to know what moves. We want to know what actually moved. So maybe we're going to have something like moving objects or something like that. Okay, this is the first vector I'm sure I have to make. Moving faces. Well, moving objects, you could say. We could have this one. Okay. So now we can have, well, a single step. Namespace collider data. Do I want this? I don't know. I don't know if I actually want this. I mean, I guess I can start making it, right? I'm not sure about that part, but yeah. Because what is the player going to be? Is it going to be a space too? And I guess moving object. I mean, I guess it's fine. Yeah, I guess it's fine. Then we have the moving object. Then for all other objects, I suppose. Maybe not. Maybe I need a grid or something like that. I mean, I guess for now... I can check if like it's... if like they're close enough or not. But, I mean, I shouldn't have a lot of... Actually, if I have a lot of creatures and a lot of entities, then it might be slowing down a little bit, but yeah. Should be... I don't know. Maybe I need the parent space. What do you think? Okay, for now we're just going to do that. With 1 and 2. And if it's equal, we return. Which is kind of bad, but that's fine. Yeah, it's going to be pretty simple. And no, this is going to be difficult. I was planning to let's just continue. There's going to be a lot of problems, but that's fine. So we have all of that. We are gonna have... Actually, I'm just going to have a register. Oh, I also want to know if it's like static or not. It's static. Something like that. And this is going to be register object. Yeah, maybe instead of chunk and stuff, I can just collision object. How do you call that again? Collision object is character. What is it going to be? You know what? We can just check. Body, physics body, rigid body. Oh, right. I guess it's a body then. Register body. Body or collider? Collider. I'm gonna register collider. And this is going to be voxel collider. And voxel collider pair. Here we go. Data. Okay, here we go. So when we register that, face collider, so voxel collider, we are going to go there and register to moving colliders. Then we have our colliders, well, voxel colliders, well, colliders, I suppose. Face collider pairs, well, collider pairs. Okay. And when I register, I push there. And I also push. I guess I can have I can remove the pointer really. Because it's just going to be an index, right? So maybe something like that. Because I guess if we have a solver in the end, that means we want a big array, very contiguous in memory. And that's really all that matters, kind of. So we push the new one. And we're going to push... Well, actually it depends. But for all other colliders, I guess we can do that first. Boop. Colliders. Well, other collider. For all of that, we can register, like create. It's gonna be a create collider. Do I want to make it a OID? That might be... Ooh. Maybe I can do that. That sounds nice. Okay, so I'm gonna make something. I'm gonna start doing something a bit different. This time, I'm actually going to use something nice from Godot that's very data-oriented. That's probably in core. Objects. Maybe not. Template. Or ID owner. And this one is crazy. It's basically this class, this templated class that you can use to create arrays. I actually don't know if I can have this in my own class. I think I can, but it's like never... Let me actually check. So we have all of this OID owner, mutable. And it's like, oh, it's still in the class. Okay, it's inside the class. But it's mutable. What is that? What the fuck? What? PTR owner. Oh! Oh, you have... Oh, you have OID PTR owner for like polymorphic types. You have OID owner for non-polymorphic types. Oh, I see now. I didn't know that. Okay. But in our case, we don't need that. We just need this. And what's really good is that, as you can see in OID alloc, we basically have this, which is pretty neat. Which is, well, not this, we have this, which is a double array, I think, that is optimizing things a little. That is making things contiguous when possible. So this is really great. And yeah, instead of this, I guess we are just going to have collider. Do I want this actually? Oh. Oh. Can I loop over everything in there? There's no begin. Get or null, make or ID. Okay, so I guess I still need my vector of pointers. Or maybe I want the opposite. Actually, never mind. Does that ensure that everything is... Oh, that won't actually. I don't think... Double list, wait. I don't know if everything is fixed or not. So allocate or ID. Grow chunks. Reallocate. Oh no. Wait, so it's moving in memory. Wait, that sucks. That sucks for sure. I was hoping for like a double links list or something like that. I don't know. Like I did. But I mean, I guess it's fine. Or is it? No, it's not. But if I make it, if I turn it into a pointer, then it's going to be even less good. Wait, that sucks. Everything sucks. Does it has to be a U object? I don't think it has to be. So maybe I want... Maybe I want this. Maybe I want this. Moving colliders. I guess I want a pointer. Maybe it's like indices like instead. What this is. Something like that. Wait, can I very easily compute? No. So in this case, I guess this is fine. Do I want indices? I mean, if I keep pointers, it's kind of bad. I don't like it. Maybe I should just have like U object or something. No, never. ID pointer owner. Right, it's pointer owner. Yep. Okay, let me just take a look at this. So you just have a pointer there. That's the only difference. I don't think it has to be a U object. Seems to be fine, even if it's not. I'm still going to store them there. Maybe. Maybe not. I mean, this is actually what matters. Only this. Not the rest, not really. Wait. That's just going to be... I mean, this one is wrong, that's for sure. But, is that like going to be an int or something like that? If it's an int, then if I remove a collider, it's not going to be great anymore. It's not going to be static. Ah. The only way is if this stalls colliders. And all of those are IDs. indices. Then we have the indices moving and now. Yeah, but then I'm not sure if I'm going to have the right order or not. Wait. Yeah, index. What do you mean index? It's not. That's not how it works. Let me just check. Let me just ask GPT really. Photo IDs. Well, C++ ID owner. How can I make it so my data is contiguous? Yeah. I mean, yeah. Yeah. Nah. I don't know. I don't know about that. I don't know about that. Well. Should IDs always point to the same data? Or when removing an item, is it allowed to change? Yeah, it's stable, right? That's what I thought. So basically, this is an indirection layer. Yeah. Let's have what? I mean, I guess I'm gonna have, well, what if I want contiguous collisions? Is there a class in Godot that allows me to allocate pointers, maybe an allocator, pointers that don't change, well, that are not reallocated, but that are contiguous in memory with pointers of the same class. No! What? Stable, contiguous. Page allocator. I mean, this one looks nice. Oh, allocate objects in fixed size pages. Oh, so that's my unrolled list allocator, basically. Objects are fairly cache-friendly within a page. Object addresses remain stable. Pages don't move. No per object heap allocation. Yep. Objects are not globally contiguous. That's fine. Local vector, batch allocation, vector, ECS style sparse sets. I do like that, but objects move during compaction, but handles remain valid. Yeah, this is basically our dialog. That's what I thought. Local vector. Stable pointers. I do want this. And that's, well, that's fine. And then local vector plus a handle. Let me think. Because other systems store pointers to chunks, because you specifically want the collisions broad phase. I want pointers. Because if I store IDs, well, indices, and I remove objects, indices become invalid. So that's when the ECS style parse set will be useful, but I don't think Godot has it. Well, it has already alloc actually. So that's why I wasn't sure about that. Yeah. It's a table. Yeah, but I don't want to re-implement the wheel. So already alloc, I guess. But it's gonna reallocate. Wait. Yeah, but indices. Indices. Oh, or IDs actually. Right. Allocate every chunk separately. Oh, that sucks. Indirect pointers. I mean, I guess I can just use or ID for that. Handle-based dense array. So, wait, what? Handle-based dense array versus stable pointers. Stable pointers. So do I want pointers or do I want RIDs? Kind of. That's kind of the question. Because there was, how was it called? Page allocator. That sounded really good. That I might want to use. But basically, the alternative would be to have, instead of indices, I would have RIDs there. And I would just sample from the, well, I would get my data from the RID owner every time, but that means there is, you know, like there are multiple problems, I guess. The first one is like reallocation, and the second one is if I get from this every time, like get on L, that means I have to go through all of this, right? Validator, there's a division. I have like a double array access. And wait, it's not finished. We have all of this. We have return pointer. Yeah, it's like not that much actually, but it's still a little bit, right? But if I have pointers, it's like really very fast. So yeah, what did it say? CPU reads the pointer array contiguously, and then references each chunk. That costs 1 extra pointer nodes per chunk. But if each chunk contains hundreds of thousands of voxels, that indirection is usually negligible. Yeah, I mean, I was thinking about doing that. I'd probably not make the chunk itself contiguous. Instead this. Yeah, I mean, that's what I was thinking about doing. So the addresses never change, and everything is good. collision loop is extremely performance critical than a handle-based dense array. Right. For most voxel engine, stable pointers plus contiguous array of pointers, a good balance between performance and simplicity. I mean, it's not truly contiguous though, right? Wait. Handle-based dense array. I mean, the dense array is nice. Well, yeah, I mean, okay, yeah, no, never mind. Dense array is good. But yeah, I don't know. I don't know. If I have a page allocator, I can have RA list pretty easily too. Maybe just check the implementation of page allocator, because I think this is really the only thing that matters. Because I think the implementation is actually very similar to RIDs. And this isn't actually what matters. This isn't what I want performance for. Really. So core templates page allocator. Okay, I'm gonna include the whole core templates. Page allocator. So now I want this and thread save for default. Oh, that's a lot. Wait, that's a lot. Do I really want that? Which page? I'm not sure about that. But if I go in, I should have a lot of things with page pool, available pool. Yeah, that's it. That's good. Spin lock, and this is probably what I want. But not really with this though. So let's have something like instead. Let's make it still a power of 2. Maybe something like this. Should be fine. Well, let me ask. Is it fine to have page allocator only have a size of 256? Yes! That's wasted memory. I mean, I guess I'm not going to have that many spaces. More page metadata. One thing to check, compute size of chunk, then multiply by... Oh, wait, that's... The result is somewhere, I'd consider that a very healthy page size. Right, that's in byte size. So let me maybe do a size of. Do you know const-text? Yeah, I do. Like to compile things during compile time. Well, it's like to call. Not necessarily, but you can basically call functions during compile time, right? And you can also use variable during compile time. Like it can act like some kind of inline, I guess. I actually made a library, a math library, to like basically where there are matrices, where you can compute a lot of things in compile time, like even the inverse of a matrix, and like with different sizes, with a different amount of rows, of columns and stuff, and you can compute the inverse and a bunch of stuff from that. It was nice. It was using CRTP. That's like curiously recurring, or CRTP templates programming, I guess. Is evaluates conditions only during compile time. A good definition for that. Is evaluates conditions only during compile time. That sounds like if const for me. Like if you have, I mean, I guess it's still const, right? But in this case, basically what it's gonna do is just, it's gonna, at compile time, it's going to remove a branch. It's gonna remove like the condition and just replace by the content you have inside the one that is right. But I would call that if const. That's very specific. Const in general is really to compute things in compile time. So for example, you can have Fibonacci maybe. Int Fibonacci, something like, I don't remember the exact function, maybe something like return. I don't remember. If a equals 0, return 1, like something like that. And then you have return Fibonacci a minus 1. Wait. Plus a minus 2. And you have if this is less than 3 because you want to handle 1 and 2. I'm not handling 0, but that's fine. I guess you can have this, and then you can do v equal Fibonacci 5. And if you put const there, it's going to basically replace v by the result of that function at compile time. So like even if you have a really big number, during the runtime it's gonna be like instant. Let's have a constant value expression not folded to constant due to excessive const function called complexity. So okay, it's too big basically. Like the recursion is too big, I think is what it's saying. Maybe something like that. Yeah, okay. Is it too big? I don't know what the limit is, but I guess there's a limit set by the compiler. I guess you can, you know, like it's recursive, so it's like very bad for Fibonacci. You might want to make a table instead, but that's like very fast to write. So that's the example I took. I only what? Only know what? I only know CRTVS. What's that? Is that Google Play? What? AI? Oh, TVs? Yeah, oh, CRTVs. Yeah, I don't want to distract you. That's fine. Yeah, basically CR. Well, yeah. I was gonna explain curiously recurring templates, but let me send you the link to Wikipedia maybe instead, because it's a very it's Python, not programming. But yeah, it's a very fun pattern in programming. That's worth looking into it. For like basically, it's so you can have compile time polymorphism. Kind of. Well, yeah. I mean, that's like, you know, there's like the simple way with like containers and like iterators, right? But anyways, right. What was I doing? Page allocator. Okay, I have this. So this is going to be colliders. Allocator. Thanks, you're welcome. Now I'm going to allocate, construct. Can I construct new allocation? Which one am I supposed to call? Wait. Can I unlock? Let me go inside. So realloc. So I have no menu. Oh, menu placement. Wait, so there is a placement. Ew. So there is a placement. And it's calling the destructor there too. So it's not really an allocator. Huh? Well, I mean, it's an allocator, but like free and... Wait, you have the new... Oh, new allocation. Wait, what? Wait, what's the difference? Alloc. Huh? I mean, it's completely different. New and okay, new and delete are the ones we want, but for some reason the menu and the destructor are called in the free and the alloc. That doesn't make any sense. Basically, to explain to all of you, alloc is supposed to reserve memory, free is supposed to freeze the memory, to remove the memory. New is supposed to allocate and construct the objects by calling the constructor. And delete is supposed to freeze the object, freeze the memory, but also call the destructor. And it seems like it's not that. There's like a few problems, right? But that's fine, I suppose. I'm just gonna do a new. That's what I want anyways. So then I have the collider that I'm going to return. Okay, now this is gonna be good. So everything is basically just going to become a list of pointers. Collider indices. Nope. Like colliders, maybe. Moving colliders. Then we have the static ones. Static colliders. Because I don't want to loop and have conditions, basically. Collider pair data. It's like, actually it's like possible, potential collision pair. Potential collision pair. That's it. And do I want this? I don't know. Oh, right, I do want pairs map, maybe? Okay, maybe that's actually going to go in its own allocator. Yeah, this is actually a lot. But yeah, colliders pairs. So about this, create collider. We are going to have a boolean. Is static or not? I guess in Unreal Engine you have static, stationary, and mobile. And stationary is basically those that can move a little, but not that much. And it's like useful to optimize a few things, I guess, but that's not really gonna be our concern. Well, I guess we're still going to have an enum for that, just in case, and it's gonna be collider movement type. So we have mobile, like dynamic, I guess. We have static, and we have stationary, like this. Are there like two ends or only one? Only one. Yeah, that's like because of French. Okay, so we have this. That's fine. So this is gonna be the type, movements type. I hope, okay, it's like already almost 1 AM, but I really wanna finish this. Well, I wanna implement the separating axis theorem. So colliders. I'm gonna push the collider. Good. Then I'm gonna switch on this. I don't have auto compression. So case static. Case dynamic. And I guess we might want to have, like, I guess defaults. And we're just going to throw not implemented. Like, I guess it's in C#. STD unimplemented. Okay, I have to import it. Maybe I can just throw. What was it? I think there was a function from Godot that was doing this. Godot throw error. Assert push error. Assert is fine. But can I have... It's not really assert that I want. Assert, use assert. Push error. Whatever. Oh, C++. I have to ask in C++. SCD runtime error. Air, right. Air fail. Air crash, maybe? Like air crash. That's assert. Well, I mean, I guess I'm just gonna have a air fail. That's fine, I don't want to crash the whole engine, the whole game. Like maybe fail. Air fail. Yeah, that's it. Like, do I have air imp? No, I don't. Okay, air fail, that's fine. Let's not lose time with this. So then we have the static colliders. We push this. Then we have the dynamic ones. Well, in dynamic colliders, surprise. Wait, what? Moving. Oh, right. Dynamic colliders, it's better like that. And then we have the pairs. Okay, let me just think a little. Before the pairs, do I have to do something else? Axes. Maybe I need a boolean to say that it's like obsolete. Obsolete. Or like dirty flag. Like is dirty. Yeah, is dirty, it's fine. Perfect. Well, I suppose. Okay, so we have all of this. So we have our new collider with like the movement type. Do I actually want a boolean there? Maybe not. Okay. Because we already have the type there, right? Like it's in the right array. And that's it. Voxel collider pair data. I mean, this one is definitely gonna need an allocator, I think. It's potential collision pair. Collision pair. Allocator. So this one is actually going to be a bit smaller. And this one is going to be definitely bigger. Like, I don't like the boolean because it's taking like 4 bytes because it has to align. Because the int is 4 bytes, the boolean is 1 byte. So since it's like in an array, it's going to go up to 8. So I'm losing 3 bytes. I don't really like that, but maybe I'm going to be able to put like more flags in there and make it nice, but I'm not really sure. Actually, now that I think about it, maybe I don't want the flag to be there. Maybe I want it to be in the collider. That way it's better because this one is going to be a lot more... Well, there's going to be a lot more pairs, right? I think, I believe. I hope. Well, I don't hope, but yeah. I'm not sure about that. But anyways, so we have the allocator. Because I guess ideally we want to deallocate, which should be pretty fast with how it's implemented. But yeah. So for now we're just gonna have something very simple. So no matter what, if it's well, no matter what, it might collide with dynamic objects, right? So something like dynamic collider in dynamic colliders, and we want to create a new pair from this potential collision pair. Well, you know what's potential? We're just going to remove the potential. So I mean, we can remove this. Instead, we can have the pair allocator. The new. I want it to be a pair. Here we go. Axis start index. And I guess I want to allocate from that. So this is going to be my big array. That might take some performance from time to time because of the resizing but I suppose it can be fine. I guess I have to resize maybe ahead of time. So this basically SAT axis. So when I add a new collider, I need the amount of axes. That means every block inside is going to have the same axes. Well, that's fine. Well, actually, never mind. That's fine. That's how stairs in Minecraft are too, right? Like it's still the same axis, even though the block is like cut. So that's good enough. Okay. So, I mean, let's set this thing axis start index. So we're gonna resize, initialize maybe, that's fine. I need to know the different axes though. Do I? Maybe I don't need to know that, but at least the amount and the axes so that I can reserve and have this equal the size. Here we go. So it's a bit unsafe, but that's fine. So the amount of axes, like this, maybe. And then we have the, wait, the pair. I mean, I guess I want the start and I want the end, technically. So that gives us the size. Or maybe, do I want the size directly? Axis, maybe NB axis, it's fine. Plus plus, while it's not equal to... Yeah, I suppose it's fine. I just won't be able to modify it very easily without resizing a bunch of things, but yeah. And aside from that, it's not supposed to change that easily anyways. And aside from that, we have the pair. That's going to have a start. We can find the amount of axes from the pair, so that's fine. And we basically can push back. I actually don't have any. Well, actually, I guess we have this. I guess that's fine. So we are gonna have our pair. Two pair. We are gonna have the pair. I think it's supposed to be fine. And this is gonna be equal to the new allocated pair. Oh, right, I have to... Okay. Well... Pair... data, let's say. And then we have the key. And this is gonna be the current, well, the new one, and the dynamic collider, like this. And I can't set it because of this, it has to be a pointer. Good. And the start index is going to be, what is it going to be? Right, we have to, okay. So about this, we have our two colliders. And as we said, we have different axes. But what? So let me show you something for the context. Rotating axis theorem. So basically, the theorem says that if, well, let's say you have two convex objects, right? It has to be convex. Oh no, right. Anyways, for two convex objects, if they are not colliding, then there exists a line, or in 3D an hyperplane. Well, a plane in 3D and in n dimensions a hyperplane. There exists an hyperplane that separates, that splits the two objects, and that hyperplane is actually orthogonal to one of, well, to either one of the normals or one of the cross products of the normals of the two objects. So that's why we need the cross products and stuff. Look at this. Because, for example, if you take the normal of box 1 there, you can see that obviously you can have a line that splits them. So resize. Do I want to resize there? Maybe not. Maybe not. I want to resize all at once. At the end. So NV axis. Yeah, let's do that. Let's do next axis start index equal this. Okay, so we have this. Then we have plot equal NV axis. But is that supposed to be the new? Yeah, it's the new size. So at the end we have this. We have this. Next axis start index. Yeah. Well, I guess it's without the E. Next axis, a single one. And then we have here. What I wanna do is something very similar. That's why you can just allocate everything at once. And index, okay. So this one, per data, is going to be equal to the current one, obviously. But then we want to increase that because the size is going to be a lot. The size is going to be a multiplication. Is going to be collider NV axis times dynamic collider NV axis. So we plus plus, we increase, and then at the end we resize everything at once. So we potentially optimize things well. Potentially. It depends how many axes we have, but yeah. Okay, so we have this. We might want to put that in a function because we are going to do the same thing if the current movement is dynamic. if it is dynamic, then it might touch static objects too. So if this is dynamic, perfect. Then I'm going to have add pairs, like add collision pairs. To a private function, this is gonna be. And I want, I guess, a list with the collider. Well, A. Well, collider. Oh, my voice is dying, I don't know why. And we have other colliders. Question is, do I want a local vector or can I just have a pointer? Oh, can I have a view or something? Like vector view? Please! View. I think I saw something like that. Vector view. Does that exist? I know there was something like that. Introduce vector view. So there is a vector view. Maybe. Wait. Nope. Yeah, let's do this. Or maybe just well. Oh yeah, it's there. Vector view. I just have to import it. Maybe not. Vector view. It's in rendering device. Wait, what? Rendering device? Huh? Oh, that sucks. Wait, that's kind of stupid. Open. It's still open. Shortcuts. With a simple span. Oh, I guess span is yeah. I guess span is okay. Maybe they already have a span. Wait, do they? Oh, there is a span. So there is a span. Wait, why is it there? Yep. Okay, let's have span. So span. Pointer and length. That's it. That's what I want. So span of this. Hello, Otsu, Froggy-san. How fares the grind? Fails. I'm not used to that word, but everything is going fine. I'm planning to implement the separating axis theorem tonight. So basically I'm making my custom collisions, and I'm making my custom physics server for that, to optimize things, because I'm afraid it's not going to be what I want otherwise. And yeah, that's basically it. That's hardcore. It's not really hardcore, it's actually pretty simple. I did that in college already, so I know how it works a little. And I made basically my own Actually, you know what? Let me show you. Which one is it? There. Here we go. So, well, I guess there's like the custom engine with editor, CPU rasterizer, okay. Animations. Yeah, I'm gonna have to make my own 3D animations since I'm remaking shaders too. So basically I'm remaking the whole engine, right? And physics engine. I guess this one is in 2D, but there's also this one where I implemented like some things in 3D with like for not cubes, but you know, like the rectangles in 3D. And you know, it's basically this kind of stuff. So I'm kind of used to, I kind of know what I'm going to go for. And we're going to use an algorithm called the separating axis theorem. That is pretty simple too. Do you know about it? Basically, it's a theorem that says that if you have two convex shapes, that means shapes that don't have like holes or like, you know, concave things, you can put a line or like a hyperplane in 3D and more dimensions that separates them. And what you do to find that line or that hyperplane is you just get the normals. You just get the normals and you also compute the cross products. I think it's like for the corners. And that's basically it. I'm only letting Claude Fable make spaghetti code for my game. I don't know anything. Oh, just registered as a Steam dev. Got it. That's fine. But yeah, I mean, we're gonna see that together then. It's pretty simple, really. I mean, add collision pairs. Yeah, I guess I'm just gonna add this right now. But I'm trying to have things a bit performant in case I have like a lot of entities and stuff. But it's not really needed. Well, it's good, but you know. Basically the goal, like, you know, basically in Godot and like other game engines, collisions work by having different colliders. And, you know, it assumes that your collisions are going to have a lot of different normals and stuff, right? Like what? Basically that you're going to have a lot of objects with different transforms, right? But since I'm having chunks, since I have chunks, basically I have a lot of cubes that are going to have the same normals. So that means I can optimize things pretty well with the SAT algorithm, the one I just talked about. I'm making a roguelike, so I need to run 40 playing styles. I identified against the mechanics and look at the results. Oh, okay. Sounds nice. Don't you want in your roguelike to add collisions, custom collisions? Just kidding. Okay, we're gonna put that there, I suppose. So next, all right. I mean, I guess I'm just gonna put this there because I want to optimize. That's why it's private, right? What I put in private most of the time is like used for optimizations. And what is public is like what's nice to use. Dynamic collider. So it's like other colliders. Wait, what? Oh, I need the... Yeah, my bad, I forgot about that. Boom. Well, over Collider. And I have the ++. Maybe I want a reference. Or a return. Something like this. Collider. Wait, I need both. So like in this case it's static colliders, and in this case it's dynamic colliders. It's a city builder, so it's very basic. No need for anything, as long as you can place buildings. I see. Wait, it's a roguelike. Wait, what? It's a roguelike city builder? How does that work? I don't think I've ever seen a roguelike deck, not deck builder, city builder. Yeah, whoa. Sounds fun. Now I'm kind of interested. Well, I was kind of before too, right? But, yeah. Do you have a Steam page? You said you registered, right? Maybe you don't have it yet. I can't tell more until it's released, though, because you never know who's watching. I mean, I do think IDs are very cheap, or like, maybe if you have like, if you give me like a 500-page document, then, you know, maybe it's like a lot, but, like, I think like just with like one ID, you can have so many different implementations. Like, look at Palworld and Pokemon, right? Well, it's like pretty close, really, but yeah. Nay, they still need to verify and stuff. Okay. Yeah, I just said nay for some reason. Nay, you villain! I'm really bad at talking like dialects and stuff. Yeah, but I'm just a random guy, and some corporation could do it faster with more marketing and everything. I mean, maybe. I understand the argument. I mean, I understand the argument, but I'm streaming the development of my own game, right? So, you know, I understand your argument, but I'm totally not considering it for myself. Because I can make maybe $5 in 5 years of development thanks to that. It's like to, you know, to finance the dev. It's like really nice. I'm optimizing my time. It feels like the right thing to do, even if it's just 0.001% chance. Yeah, I see. I do think... I mean, I guess what I want... I think what's really important... Maybe not. Well, kind of. I was gonna say, I think what's important in game development, a little, it's also important for other things to me, but in game development, I think it's important, is that you want your studio to get like some reputation. As in, you know, like usually people, like studios make a few games before they become like successful or that kind of stuff, because you slowly gather more and more players, and like you slowly build a community. And I think that community is important. And what I'm trying to do by streaming is, I guess I'm trying to build that community. And to me, it's like more important than, than just giving IDs. Because IDs, you know, like it's just IDs. Like, you have so many games nowadays, you have so many different IDs, that I don't think it's worth it to like gatekeep IDs. That's why I'm making my documents available too, right? It's because, let me show them again for people that watch the VOD or anything. You know, my documents about game design, marketing and stuff, puzzle, all of that, right? Basically, I do think IDs are really cheap. But community is important. And by making those documents, well, you know, it's like useful to other people, and I can grow my community a little. And yeah, I mean, like, if you know someone else becomes successful thanks to that, then it's good, right? Because it's like, if my community becomes you know, better, like gets better in value, then it's kind of good in a sense. I want my community to be successful. Your game is multiplayer, right? Not yet, but it's planned to, yeah. It's a plan. I want first to have collisions, to have ambient occlusion for sure, and to have some basic gameplay with like basic entities and inventory, that kind of stuff. But then I'm going to tackle the multiplayer. That's on the roadmap. So okay, we have this. Yeah, mine is single player, and people will compete by score on a leaderboard. Oh, okay. Oh wait, it's a city builder, right? Roguelike city builder. Oh, that makes sense. That makes sense, I suppose. I mean, if it's like oh, wait a second. So it really is a roguelike. Wait, that doesn't make... Wait a second. So the community aspect is not the same as with people being together in the world. Yeah, but I mean, like, even with my previous games, right? Because, like, this is, like, the first multiplayer game I really planned to do. But, like, all my previous games were, like, single player, right? And I have a lot of those. So it's not as if, you know, like, even in single player, like, the community is still important. Even if it's like, you know, together in a world, right? But yeah, I mean, I understand what you wanna, what you mean. I guess to me, from maybe what I've learned through my different tests, I suppose. Basically, before making Steam games, I failed my first one, I guess. I have a demo, but it's a bit of a fail. But before that, I tried a bunch of games for like jams, basically, game jams. And I guess I kind of sharpened a little bit my mind about marketing. And to me now, marketing is like very important. But what I mean by marketing is not advertising, it's also making the game. To me, marketing really became a big part. But it's not, because, you know, in the end, like, whatever your goal may be, is probably to like have players play your game, and for that means you need marketing. It doesn't necessarily mean selling, right? But if you want your game to be played, it means it needs marketing. And to me now, like for a lot of people, I guess you have, like, for example, programming, right? Maybe you have like art with like tech art there, right? That kind of stuff, right? Something like that. Then maybe you have sound. That might be a bit there. So like sound. That kind of stuff, right? And I think for a lot of people, marketing is like, I'm just gonna call it mark, right? For for a lot of people, marketing is just like there. But to me, it's like actually there. Maybe you can say it's like there, okay? Maybe this is marketing. Okay, this is marketing. Because the art you make is going to be, you know, what might attract players to play your game. The sound, like the music you make, might be the reason a player is going to play your game. That was the case for me with Ender Lilies. And like art is like was the case for me for Ender Lilies too, and a lot of other things. And programming was the reason I played Minecraft, right? Because of voxels and stuff. So like really everything is like marketing. And that's why I think, well, I mean, I guess with my test with like game jams, like basically if you just make a game and publish it, like, you know, put it in a game jam, like not a lot of people are going to play it out of the blue. Well, okay, first, if you make a game and put it on itch, no one is going to play it if it's like not incredible. If you just put it like that, but just by putting it in a game jam, you start having like a lot of players because, you know, you have like some people that play games to rate them and that kind of stuff. And then you have the whole community around it. And, you know, like you can like have people play your game and then you play theirs, that kind of stuff. And, you know, it's like some kind of community and it's like kind of marketing, I would say. And what? And yeah, if you tailor your game to your target audience, you're really going to have a lot more players. And I guess that was the case for me. That was very stupid, but I basically tested my theory, like one of my documents about game jams. That's basically in game jams, you have meme games, you have memes, and this one, actually it was the latest one, oh, and this one was basically the peak, the culmination of my learning, of my experience. And as you can see, you have so many people giving comments and stuff. Meanwhile, I guess you have like a few other ones like where you have like a lot of comments. This one, okay, this one had a few comments because I actually made everyone participate. I had like 79 people draw like each one a character in the game. That was nice. And yeah, you know, like even if this one has like nice art, in the end it doesn't actually have that many comments because I didn't actually interact with the community that much. And I would say that's like one of the differences. So the community aspect is not the same as with people being together in the world. Some Twitch streamers I know might play it. Oh, which one? Who? Oh, wait. Oh, yeah, okay. Yeah, like, I see, like your game. I mean, yeah, I would definitely play it. So yeah, definitely, definitely, yeah, sure. If it's like nice, and if it's free, and you know, maybe like giving some review. I don't know, might be nice. If it's short, I mean, it's supposed to be a roguelike, right? So I wouldn't mind trying it out. I mean, I guess I try to work a lot on my game, but I mean, I might definitely consider it at least. Okay, so there we go. I mean, okay, that's good. We have a nice insert. I guess we want to destroy too, ideally. So I'll give you a free early access. Oh. Would be nice. But then, I guess someone, well, never mind. Okay, so now we're going to destroy the collider. Boo, boo, boo. Here we go. And in this case, I want to remove it from... I mean, it depends what it is. I guess I'm gonna remove it from here. Do I want to... I guess I can just remove... like swap and pop back. Oop, this one is there. So I don't think there is a swap. How is it called in Unreal Engine? It's like Unreal Engine F vector? No, T vector, T array, swap, something. Oh shit. T array, swap, something like that. Remove that swap. Yeah, remove that swap. Okay, that's it. So erase the swap, maybe. Remove swap. Right, remove swap. So we're gonna have something like that. Remove swap, maybe. And I'm going to put that in my helpers. Yeah. Remove swap. And remove add swap. But I meant some streamers who might love the game because they're playing similar things. And then of course the audience might become interested as well. Yeah, that's definitely the right thing to do. Like, I mean, if you make something like a roguelike city builder, I mean, I don't know any roguelike city builder. I suppose there are some, maybe, that exist already. But, you know, I guess it's... I mean, if it's niche, maybe it's good. If you manage to find that audience, then it's very good. If you don't, then it might be a bit more difficult. Like, if you make a roguelike deck builder, then you might want to... I know it's not your case, it's an example, because I tried to make one. But a roguelike deck builder, you know, you're going to join communities like the one of Slay the Spire, or like that kind of stuff, right? So remove that swap. We are going to have the local vector. So I guess it's templated. Are there multiple? Shit. Do I want this? I guess that's fine. So we have this, we have a reference. I mean, it's gonna be just a single one like that. So array. And remove add. So we have the index. And this one is gonna have the value. Oop. Something like this. Like, I guess a reference. Is it? Yeah, because it's already in the array. So that should be fine. Maybe const. I mean, I'm gonna remove it. That's fine. So now we have the find, which returns an index. Yep, like, is that like index? No. So find. We have the value. Wait, from? Wait a second. Yeah, that's the value. In 64. Wait, isn't there like a type for like the... Huh, interesting. Interesting. Find. I don't understand. That's fine. Yeah, I also like Slay the Spire, even though I usually never play card games because I enjoy the hardcore mechanics. What? So my game is also based on HC mechanics. HC? A guy keeps asking me to show him the game, but I haven't actually seen it since the first day, like 10 days ago. Oh, HC equals a hardcore. Got it. I mean, card games can become pretty difficult. Even though I usually never play card games because I enjoy the hardcore mechanics. What do you mean by that? Do you mean... What do you mean by hardcore? Do you mean like reflexes and stuff, like managements? Or do you mean... Like, is that a different dimension that you're talking about? Or... Because like card games, like... It's pretty difficult, man. Maybe not in Slay the Spire, but... Oh, well, I guess maybe you're talking about more difficult than Slay the Spire. I mean, deep mechanics where you need many runs to explore them, and there are satisfying payoffs to learn them. Yeah, okay. Yeah, I mean, maybe Slay the Spire is maybe too simple. I haven't played it, but I studied it a little, I guess. So I know cards are simple. I'm not sure about the overall complexity in the end. But yeah. I usually never play card games. I mean, card games are pretty difficult, man. I don't know if you are realizing, like, I'm thinking about Yu-Gi-Oh, for example. Like, I guess Yu-Gi-Oh is pretty... its own thing, right? But I usually play strategy games. I mean, card games are... I mean, okay, roguelike deck builders have some strategy. Mainly about building your deck. But also a bit in battles, depending on the length of the battle, maybe. Even though you might call that tactic instead. But yeah, like card games like Yu-Gi-Oh, like... I mean, okay, Yu-Gi-Oh became a lot oriented towards tactics, my bad. But I would say it still has, like, old Yu-Gi-Oh had, like, some nice strategy and stuff. Like, just building your deck. And, yeah, no, it definitely has some strategy. Like, TCGs in general. So playing STS, Slay the Spire, is an exception. Got it. Yeah, I mean, Slay the Spire is a roguelike deck builder, so I guess the strategy isn't really in the card battle. It's really in building your deck, I guess. But yeah, well, so it's not maybe that complicated. But yeah, card games can definitely be very strategic. Like, basically, the longer Well, yeah, I guess. Okay, so I was gonna say the longer a card game is, the more strategic it is, usually. And in Yu-Gi-Oh! It's actually pretty funny, because the strategy has been removed from duels, but it has been moved to before duels. It has been moved to when you make your deck, when you build your deck. So like all your strategy is actually also in the deck building part. So I guess it's the same as Slay the Spire in a way, but yeah. Well, it's very different still. But I would say it's like very... I mean, I guess you can just like buy you know, one of the popular decks and that kind of stuff, right? But like without talking about that. Like for example in, you know, like console games, like I'm thinking about like a DS game I played, like a Yu-Gi-Oh! DS game, where you could like make your deck like rather freely. Like I guess you have Magic the Gathering, but I've never played it. I played a bit of Hearthstone, but quickly got tired of the pay-to-win aspect. Yeah, got it. Makes sense. Let me actually check something. Okay, never mind. I'm not gonna talk about it. But yeah. I guess I got into Yu-Gi-Oh! As a child, so it's like it's been a bit easier for me. But well, it definitely has a lot of strategy. And I guess that's kind of what I tried to do with my game. Like, I guess if you want if you want an example of maybe something that doesn't have a lot of strategy yet, but that has some base, you can try out my game, and it's not like very push, right? It's just a demo, right? But I tried putting some strategic elements into it because that was kind of one of the goals, because I love strategy too. And you know it's free, right? And it's like maybe like 1 hour if you want to check things around. Check out Europia Universalis 5. It's my current 5 game. I'm actually not familiar with it at all. Oh, actually, I think I saw it. Mixed reviews, oh no. Oh no! But yeah, okay, I see. Yeah, some kind of, I'm gonna say Civilization kind of game, but I've never played Civilization. So yeah, basically country management, wars, I guess, that kind of stuff. Yeah, okay. I've seen it before. Wait, was it the game that was like good to learn about history because you have like historical events in it and that kind of stuff? Maybe that was the game I've heard about. They can afford the mixed reviews. People still buy it. Got it. And it's like kind of expensive. I guess it should like attract like a niche. It probably attracts a niche. I I know some studio in France that was doing the same. That was having like its niche of players. And even though it was like using a custom engine that was a bit old, it was still working. There's no competitor of Notch. Oh. Okay. Okay, so good luck making... Good luck. Wait, was it your first... was that your first game? I mean, yeah, it was my first Steam page, you could say, because it's like still a demo, right? But it's like not my first game. Like I've put games on itch, I guess. For example. So remove that swap. Let's actually implement this. So remove that swap. We have the array still. Now we have the index. And what we want to do there is we want to have the current index be a move of the last element. Maybe. Oh, actually I want to wait. I want to delete the element though. Do I? Maybe I don't want to actually. It depends. It depends. Never mind, I'm not gonna delete it. So move back. There's no back. I hate it. I hate it so much. You know what? I'm going to make a back function. Because I needed it like a few times and I never have it. So T. Like this, I guess. And it's gonna be return array dot... Well, array dot size -1. That kind of thing. And that means now I can do back of the array. So I move it and then I pop. I need a pop. I don't have a... I hate it. Why doesn't it has like anything? Like ideally I just want to add it inside the class, but I don't really want to have like conflicts with the new versions of Godot. So pop back. And pop back. I guess, do I want to return? Not really. I mean, ideally I do want that, but that's fine. And this is gonna be a resize of array.size -1. What are you doing? Hey, hello! Let me show you, it's incredible. I'm basically making my own custom engine. Well, on Godot. Well, I'm making my own collisions. But I guess the goal is to have some game that's a bit like Minecraft with different blocks, right? But the thing is, instead of just, you know, a flat world, it's actually a donut. It's actually a donut. So it's slow to generate because I'm in debug. But like for example, if I have like some tower there, I can just, you know, continue building that, well, a bridge, you could say. And if I spam click a lot, yay! You can see that it's slowly starting to curve because it's actually a donut, as you can see. Hello? Okay, are you here? Are people here? I'm sorry about that. Okay, the stream just resumed. Oh, Amaya. Okay, Amazing, are you still here? I'm sorry about that. I tried running my game, but for some reason OBS just crashed. I don't know why. Maybe because I don't have enough memory, but that's probably the case. Actually, that should be fine. Wait a second. Okay, here we go. Actually, wait a second. You're good now, thank you. I'm just gonna remove this. Okay, is my cam going to be fine? I hope this was just a coincidence. This is me, sorry about that. Okay, my cam is fine. I'm back. And I'm going to try running my game again. Menu is now. What? Huh? Oh, menu. Okay, so that means there is not enough memory. Wait, how is that possible? So I have currently 24 gigabytes on my disk, but maybe it's on my RAM. Okay, let me try again. Okay, it's good. Can you see? You can see, right? I don't know when it crashed, but maybe it was a bit too much for my computer. Okay, so it seems to be fine, right? And yeah, basically this is a donut world where you can put blocks, where you have like some biomes, I guess. Oh, maybe that was when I got the big freeze. Got it. Oh, because of collisions. Yeah, because I have collisions enabled. Let me remove collisions, because they're pretty bad. That's why I'm remaking them. That's why I'm making my own custom collisions. Here we go. Okay, here we go. We shouldn't have any more crash now. And yeah, we can just loop around. We have biomes, we have big holes, I guess, and we just go back to our previous position. That's it. I lost so many people. No. Okay, but yeah, tonight, okay, it's 2 AM already. Oh no. Okay, maybe we're going to have to stream up until 3 AM or something like that. Voxel helpers. Okay, let's remove and swap. So we're just gonna pop back the array. And that should be good. And now I'm gonna go there. I'm gonna include voxel helpers. So modules, voxel, utils, voxel helpers. And this is gonna be nice. Probably. So destroy. Right. So this was remove swap. And we remove this collider. Well, this collider. And other than that, movement type. I mean, yeah, depending on this. Oh, I actually don't have the movement type. I'm not sure about that. Do I want a RID? Do I want another class that represents this? Do I have to pass? I'm not sure. I guess I want things to be really optimized. So that's why I'm not sure about passing like some additional data. and increasing the memory. I mean, technically I can just remove. It's just going to be very slow, so that's why I don't like it. But I can always erase. Well, not really erase, like remove swap. And yeah, if it is -1, what happens? Then it's gonna return false. Else it returns true. Here we go. It's Boolean. Yeah, should be good. Wait, 2 seconds. Boo. Okay, my bad. I'm back. I'm back. So, remove swap. We have this, and I also want to check. For now, I'm just gonna do that. It's like not really optimized, but yeah, to do optimize by storing type. Sorry about that. Let me actually, you know what? Let me just pass it as an argument again. Here we go. I don't really like it a lot, but it's fine. So you have the movement type, and I'm going to do things depending on this. Depending on this, I'm gonna erase it, or like remove and swap. Well, remove at swap the collider. Right, I also need the array. Index, right. It's a remove swap. Petit colliders. Bonjour mon ami, salut Saloon. Salut Saloon. How are you? How are you doing? I love this music so much. So basically, to give you the context, Saloon, I'm making my own custom engine, my own custom physics engine, my bad. Well, I already did the renderer part, right? But yeah. So we have removing the colliders. So I push. I don't have to remove the resize, which is nice. And the collision pairs, right? So I have to remove the collision pairs first. But after this. Right. Wait, I need to add this after. Wait a second. Oh no. I misplayed. That's fine. I'm gonna push that there. And then I'm going to do the opposite. Don't bother explaining it to me. I'll forget for 2 seconds. Well, in 2 seconds. Okay. I have the brain of an unborn child. That's fine. I like children. Never mind. Never mind. So. Collision pairs. Right. Wait, that's... I'm actually not sure about that. Well, I guess I can just get the pairs. And that should be fine. Like, oh wait, it always has to be... Wait, the pair is like ordered. Do I have like a unordered pair? I don't. Oh, that's bad. Pair sort. So I'm gonna make a new class that's called unordered pair. I figured out you started working on collisions. Oh, thanks. I'm thirsty. Oh. I'm thirsty too. I'm gonna drink a bit more. Let us all perish. Our thirst together. Yeah. Well, not me. We shall overcome this obstacle. Yeah. I mean, I guess I'm just gonna... I just need a function for that. Like name A or like T. And it's gonna be a make unordered pair. And this is actually going to be ordered. So we have 2 pointers. That's important. And we are going to return a pair of T and T. Well, I mean, I guess pointers, okay. And this is gonna be if A is less than B. Yeah, that's right. If A is less than B, then we return the pair PT, and we're gonna have AB. And else we are gonna return actually less or equal. And else we are going to return BA. So it's actually ordered. I actually lied. Lurk. Oh. So okay, this is it. Maybe it's gonna go in my helpers. Ah, this is gonna take so much time, 1 hour, to finish like the SAT, because I guess I wanna make things really clean. Because the other things are not clean. And I need something clean for the collisions, or it's not gonna work. At least. So make. Where was that? There. So we have this. I guess I can just make another pair. With, oh, maybe I can just do collider over collider. And that works. I don't even need to specify the template type. Crazy. So I can just do that. And this is good. And when I want to remove, ooh, what I'm gonna do is I remove from the array there, and then and then if it was, I guess I'm gonna switch again. Maybe not. So in any case, I'm gonna remove, oh, I guess I have to make something like that again. Add collision pairs, remove collision pairs. Remove. Okay, I don't need this, I don't need to optimize this. Wait, do I actually? I don't, probably. So we have all of this. Just gonna put that in here. Collider. So for each of our collider, I don't need to allocate their data. Yep. Instead, I'm just going to. Maybe I want to deallocate though. Well, I mean, in the end, yeah. So I'm just gonna first make my pair. Well, and I'm just gonna get the data from this. It is going to be this. And like the order actually doesn't matter because this is unordered. This is what's nice. Okay. So we have the data. Now I want to delete allocation. And I'm gonna have the element inside. And the other thing I wanted to do was, I actually don't know. I mean, I guess I want to remove some axes. But they might be in different places. So this is gonna be very big. The ideal thing to do would probably be to have like a vector where I store my different modifications, like a stack of modifications. Maybe not stack, never mind. Like a sorted vector of modifications, of removed indices, kind of ranges, removed ranges. And then reallocate the whole array from this. This feels very slow. That's fine. That's just when removing collision pairs. And that might actually happen quite often. Maybe not, maybe yeah. Anyways. Axis start index. So let me just have collider axis start index. Oh, right, but wait. Right, that's the index though. And I'm going to remove it. Oh, that sucks. Okay, I'm glad I decided to check this out. Oh, but I can update the indices, I guess. Actually, I'm not even sure anymore because you have some different entities that might share the same normals. I mean, definitely they are going to share the same normals. So you might want to have pointers for that too. I think I'm just overcomplexifying things. You know what? Yeah, because removing... Yeah, this is pretty bad, I think. I think I'm going at it the wrong way. For axes. Anyways, let's do remove axes. I'm just gonna do something. I'm just gonna implement the SAT algorithm. So separating, well, maybe test collision. Separating axis theorem algorithm. So basically we have this test collision between two objects. So we're going to have one collider A, we're going to have another collider B. Right, that's pretty simple. And the goal is in the end, we have this. So we should be able to find the data of the pair, like this, right? This, oh, A and B. Now we have the pair data. And if it's dirty, then I guess we want to recompute, but maybe we want to do that at the beginning. And now we have something like SAT axis PTR. Something like this, maybe. And axis A start index. Then we have the same with B. Well, let's say this is going to be A normals. I mean, I guess we can just do axis plus instead. Then we have B normals, right? It's like pretty constant. And then we have the pair data. That is gonna be, you know, this. Oop. Wow. So this is like the pair normals cross products, basically. And these are all the axes we really want. Okay, good. So now for each axis, I guess we might want something like... Right, I already have axes. Test axes, let's say. I guess for that we can just have really something like A normals, B normals, and this thing. So we have all the axes, which is nice. Now I can do a for reach of x-axis 2. Okay, I have no idea for names. Something like that. Oh, and I guess the size depends. Well, okay, so I guess I need how was it called? A span. So this is gonna be a span of vector 3. So something like axis plus this, and then we have the length. So A and B axis. And I guess I'm just gonna compute this every time, but that's fine. So we have... That should be pretty fast. Well, we just have B. Yeah. Yeah. I mean, this is like pretty instant, right? Debug enabled. Oh, they have that too. Plus 20, make this check run only in non-const eval. Oh. So yeah, basically I just assign 2 values. So it should optimize things out pretty well. Then we have this, and the amount of axes is going to be, because we have cross products, we have this times this. Right, I think. Do we? That would make sense. Yeah. Yeah, that makes sense. So we have this. Now this is an array of spans, I guess, like this. And now we loop over spans, and that means maybe it can be a const ref. Axis span with a S. Okay, here we go. Here we go. And now for every axis there. Oh, this is pretty unoptimized. Well, it depends. That's fine. I mean, I don't have a lot of... Well. Never mind. Okay, so let's do that. So we have an axis, basically. And then I want to project... Oh wait, I want to project both shapes on the axis. Wait, so that's actually going to take a totally different shape. All of that is, I think. But yeah, we're gonna have... I mean, I guess it's gonna need vertices. Collider. Convex. I'm not sure. I mean, I guess maybe something like voxel. Convex collider. And we're gonna have something like a... Are we? Wait a second. No. Actually, I'm not sure about that. Maybe I'm gonna have spans instead. So we... Maybe I want a single vector of all the vertices. So vertices. And then I'm gonna have spans of the convex part, basically. The convex colliders span into vertices, we can say. And this is supposed to be constant. Let's say. So okay, let's say we have this. That means we have convex colliders. Yeah, maybe hash maps are going to be a lot more useful than memory locality for this. So actually, you know what? Let me think about something. Maybe I want to compute everything ahead of time. That would prevent like conditions and stuff. Do I? Or do I want to compute lazily? I mean, it depends. For static objects, you know what? For static objects, I'm actually going to do that. So I want to project my shapes. What's that? Destroy. Adds. What the fuck? This. Okay, here we go. It's a bit better. It's not really good because we still need to remove the axes, but yeah. Wait, create. I mean, create. Everything delete. There. Anyways. And same that. Well, yes. So if this is static, basically the moment we add those colliders, we want some kind of map. So yeah, axes are actually not going to be the data that we want to optimize. The data we want to optimize are the vertices. I guess the convex colliders, but it's just the vertices. And we are also going to need the projections. The projections are very important because it's what makes everything super duper fast. So so I guess it's a range, min and max. Of one collider on one axis. Oh, so actually there's going to be a lot of ranges. I mean, I guess I'm gonna have to put that there because it also links to the pairs. And yeah, I don't really like this because referential. But you know what? I'm going to have some pretty dirty algorithm because I'm gonna have to go soon. Because I have to sleep. What? I have to sleep? No! Impossible! So basically... for each convex thing, so maybe it's gonna be a span. Convex shape in a convex colliders. I mean, yeah, that's kind of the same. Convex collider, I guess. Well, yeah, let's rename it convex shape. I prefer that. So we have this. For all of those we project from... well, we project the shape, right? And what is it going to be? Well, on the axis. What is it going to be? It's going to be a little function where we have a convex shape. We have a vector-free axis. And this is going to be pretty simple. For all points of the vector shape, for all vertices, vertex, we're going to do, I mean, I think it's just a dot product. Okay, it's like vertex dot axis. So we have this. We have the result, so it's like a float. So V. And we want the minimum and we want the maximum. The mean equal numeric limits for float, and it's gonna be the lowest because it can be negative. Then we have, actually it's gonna be the opposite. This is gonna be the max, and the minimum is gonna be the max by default. And now we just have max equal the maximum between max and V, and same for the minimum with min. Okay. And do we have a range? Does that exist? Car range, not really. I was gonna say I can have a pair, but that takes a little. So I'm gonna make a new class, surprise. That's gonna be called toRange, like projection range. We have the mean and we have the max. And maybe I'm going to turn that into float, but into doubles, I mean, for more precision. But I shouldn't have to. I think floats are fine. And I mean, I guess I can just spawn that. This can be assigned by default. Ah, the opposite. Wait a second. Okay. And then we basically have this. Right. It could be a function of the projection range, but yeah. I mean, definitely. Yeah, it should be. Let's do that. Something like this. So then we can remove this. Perfect. Here we go. And range, like projection. And I just do this dot project. Like maybe a from. Let me do a static version. This from convex shape. Something like this. That's going to be range, return range, range that projects. I guess convex shape and axis. I guess we can do that. Maybe we can optimize it a bit more. I was thinking, but that's fine. That's good enough. I guess my goal is to pre-compute, so I'm at least going to have those. And this is gonna be this from convex shape. And here we go. And now we can have this in one line. And this is great. Okay, we have the projection. Then we need the projections for B. And we want to store that somewhere. I mean, technically we could store that in different places. Maybe in the pair data. Axis start index. Oh, okay. I mean, sure. I mean, yeah, index is like pretty bad. I mean, I really love the allocators about this. But yeah. I think I'm gonna use allocators again. Remove collision spells. Is it something I'm gonna do often? For entities, for example? I don't know. And if I use an allocator, I can only reserve one element at a time, I guess. I mean, I guess I can reserve... Can I reserve arrays? I don't think I can. Checkmate. I've been checkmated. Okay, let's say we have the projections. You know what? Let's have the same for all convex shapes. Wait, what? Anyways, let's have something like this is pseudocode. This is very bad. That's fine. I should optimize. Well, I should have a broad face. I don't even have one. But let's have this. A projections. Okay. Something like this, maybe. Dynamic allocation. Then we have the same for B. I'm just gonna copy it for now. B, like shape, reproject, B projections. And then what we want to test is if everything collides. Was that it? Wait. For in 32. If the, well, this is supposed to be the size of do I actually have NV axis? NV axis equal this is size plus B size plus this size. Boom. Here we go, E++. Sorry, been thinking about some things. Do we have the axis? What do we do with that? Yeah, so we have this, Einstein, not at all. And we want to check if it intersects with B. So we could have something like projection range intersects, does intersect, something like that. If it does intersect, then there might be a collision. But if there is one that doesn't intersect, then this is a separating axis. And that means there is no collision. So I guess if we return the Boolean, we have this, and we return false. But in this case, we return true. And I mean, I would say that's basically it. So I just never know about intersect because it's like very easy to have like to make this function, but at the same time A, B, at the same time I know you can optimize it for it to be pretty short, and it's like always a bit difficult to find back, but this, you have this. So basically you have, for example, this case where they're like separated, like the ranges are not aligned. You have this case, this case. You have this case and you have this case, right? Let's say we have max there and the minimum there. So this is, so if there is collision, the minimum is always less than the max. And the max is more than the minimum. I think that's it. Something like that. So like the max, the max is more than the minimum, and the minimum, and the minimum is less than the max. Is that it? I think that's it, but I'm not sure. I think there might be like the other one too. I might have to check the other one. Do I? I'm just gonna GPT that really quickly. But I think this is... I feel like it's missing something. I think there's like maybe the end or from memory. But yeah, 2 ranges from min to max. How to check for intersection. I could just look at it on the internet. Okay, yeah, there's the end. Wait, actually, never mind. Or equivalently. Wait, so okay, this is actually fine. Max A, well, I guess higher or equal to B, minimum. Then you have the max B, higher or equal to min. Yeah, okay, this is fine. So, I mean, with this, I suppose. I want things to be precise, but it's like floats. So actually, it's fine. Equivalently, STD max, STD min. Yeah. Good. I'm good. Wait, if you don't want touching endpoints to count, yeah, you have this, that's fine. I'm gonna count them. So we have this. Probably. Oh, right. No need for that. It's a static function. Let's say this is fine. So then we check for intersection. If there is no intersection, then this is the separating axis. We return false. And if there is, then it is a separating axis. And I guess that's it. I actually don't remember how to compute the normals. How do you compute the normals? Wait a second. I forgot. Oh no, I forgot. Wait, how do you compute the normals from the SAT? I guess you have to find back the segments and stuff, right? So with like some binary search, because it's a convex polygon. And I also want the distance. So for each collision. Okay, for now I'm just going to keep it simple like that. And basically what we are going to want to optimize is we want to cache the projections. And this is going to be very easy because we only have a few axes for like a whole world, right? For like chunks and stuff. And on top of that, what? On top of that, we're going to have static things that won't move. It's not going to move. So, like, for example, the world is going to be static, so we can pre-compute that. And we can pre-compute any projection of a dynamic shape against the axis of a static one, which is great. I just have to, store it in a good enough ways. So the goal is to remove this, basically, is to pre-compute this. From convex shape. Wait a second. Now that I think about it, it's not very optimized, is it? Because... Wait a second. Project. This. So we have this, right? and we loop through every vertex. But we can actually optimize this because this is convex, and since this is convex, it's basically like a circle, right? Like you have like a convex shape, like this, let's say. You have an axis, and you want to project. Like from this, it's like a straight angle. And something like this. Okay, it doesn't look good at all. Wait, that's not... You know what? Let's make a line. Perfect, something like that. Okay, here we go. So instead of testing like every little vertex, right? We can actually just go, for example, from here, like have the minimum and the maximum, and you do some binary search. And what I mean by that is you take the middle point. Is this less or equal? You check the side, the direction. Wait. Wait a second. Okay, let me go here. So you have this. So from what side should I go to get to the minimum? From this side, obviously. So... Wait, how do I cut? Half? Wait, I need two different trackers, I think. Wait, so it's not some binary search, is it? Okay, I guess I actually have two trackers. So I have this one. I have this one on the opposite sides. Let me actually do it like this. So on the opposite side, which one is the one projecting to the minimum? Well, which one is the minimum, leads to the minimum projection? So we have this and this. And it's obviously this one, right? So then that means we can keep this side instead of this one, and we discard all of the indices that are there. And we basically have some kind of binary search. And then what do? We have a new test, like in the middle. And then we try to compare the two projections. So we have... Wait, what do we have? The three projections, I guess. So we have this one that we add to the mix. So it's actually some... Like you search like with three different pointers. I don't know how it's called. But you have this. You get the minimum amongst the three of them, amongst this one, and this one. And you can see that it's this one. So we keep this one. And we discard the one that is there, I suppose. Now you check there. Wait. Yeah, you check there. You have a new one that you project, and this is the minimum one. And basically you can do things like this. Depending on the amount of vertices, since we have some cache locality, I don't know. Like the speed might be a bit different. I think it's like more optimized to do that. So to do some optimized binary search, well, some binary search variant, I guess, to find the min and max more quickly. Okay, this is it. I mean, we shouldn't really have that many vertices anyways, should we? I don't know. But let's keep it like this, I guess, for now. Okay. Okay. So then we have... So I guess the goal is to get the normals. It's already gonna be 3 AM. A normals, B normals. So yeah, basically those are kind of wrong. Axis and axis cache. So we have a collider. I mean, I guess I do want to have a custom class that is about axes. Axes. That's it. Axis or axes. One or multiple. I mean, I guess multiple. Actually, I mean, okay, maybe optimization is for later. So, collision axis, maybe we can have. It's going to be a struct again. And this one is going to have a list of axes. Or like, We're actually not sure about that. Maybe just axis data. But if I'm going to put like a std vector, well, like a hash map really it should be, or should it be? Wait a second. Yeah, it's a single axis though. Hi! I'm a software engineer. Nice to meet you. Nice to meet you. How are you doing? Nice to see you. Welcome, welcome. I'm trying to make custom collisions for my game, but it's a bit complicated. I'm trying to make optimized ones because I have some Minecraft-like world with like cubes and stuff. I also have my custom renderer right now, I started making biomes. As you can see, like you have some division, some separation between the snow biome and the grass biome. It's like very ugly for now, but bear with it. And I also have some craters, some how did I call that? Rifts, you could say. Right, that's like a proof of concept right now, I guess. But yeah, I'm doing fantastic. How about you? I'm doing great. Thank you, thank you. It's just like almost 3 a.m. So I might go in like 30 minutes, something like that. Did you design system before starting with development with this one, with Sir? What do you mean by that? Not really. I just started like that on a whim. And as you can see, it's also a donut. It's not a flat world like Minecraft. It's a donut, so like if you go in a straight line, like there, you can see that we are going to find back what we just put there. So this is kind of nice. And yeah, the problem is that since I haven't designed a lot of things, like there are a lot of things that are still a bit ugly, especially about the rendering, I suppose. I have to work a lot on the rendering, but yeah, and yeah, right now I'm trying to make collisions a bit clean, and as you can see, it's warping around. I'm just really proud of this because you know how a donut works, right? Like basically, this is a donut, right? Well, I mean, I guess you can just see it there, right? But if you cut it, if you take a slice, it looks like this, right? It's like a circle. But like if each cube, let's look at this. If each cube is on top of another, right? Then that means you have a cube, a cube, a cube, a cube, and you know it goes towards the center, right? But it doesn't work. Like you can't have this for like all the blocks at the surface, right? Because at one point you have like a problem. So what you actually have is if you have a slice, you know what? If you have a slice, you actually have something like this, right? And then like each cube is on top of each other, but the problem is that you have some distortion, right? Like if you go down, it's not supposed to be a cube anymore. Like maybe there it's like a cube, but then as you go down, you can see that you have like rectangles, right? And it sucks. But for some reason, for some magic reason, I actually still have cubes, as you can see. So this is the magic of my game. It's to have cubes. I have cubes in my donut. And I'm just really proud of that. And even like as I build up, I still have cubes. Cubes everywhere. Right? And even with all of this, like when I try to break a cube or place one, it's like at the right position too. So that's why I made my own custom render pipeline. That's the context for that. And right now I'm trying to make collisions. So collision axis data, I suppose. Is it? No, axis. Because it's like some kind of referential. And we are going to have different axes. SAT axis, I suppose. And for each axis, I'm going to have What am I going to have? I don't know. I'm going to have a hash map again. From one shape to the axis. Maybe like index. So I can't really have that. Is this personal music? Yeah, it is. Welcome, welcome, Alex. I'm realizing my architecture has a lot of wrong things. Yeah, that's the problem. Like I like starting the code right away because that way I can pretty easily see what the problems are. Nice, I'm C++ solo game dev too. Oh, nice. C++ solo game dev, what engine are you using? Godot? Unreal? Your own? Custom one? Hashmap means dictionary. Yeah. No engine. Oh, custom one. Well, I guess it's always, you know, like, no engine is always like your custom engine. Even if it has like no editor, it's still an engine, I would say. So it's like pretty nice. Are you using something like SDL, SFML, Vulkan, OpenGL, DirectX? Vulkan physics. Oh. Okay, okay. Nice. I mean, I was actually thinking that I'm making my game on Godot. And it's like pretty nice because of the editor and all of that stuff. And also like the cross-compatibility thing, right? But at the same time, I feel like I could port my game onto another engine, onto a custom engine, because I'm like relying on so little things from Godot. And I guess it's kind of the same for you. Like I'm wondering, why are you making your own engine? What kind of game are you making? Because I feel like, well, Godot is free, right? So there is like no con in using it. And if something doesn't, if I don't like something, I can just remake it. And that's what I'm doing. Diablo, like, oh, I tried other engines and I hated them all. How long have you tried them? So I actually want convex colliders. And I mean, I guess it's technically a span. I'm not sure about that. I mean, technically, oh wait, local vector. Technically, it's not supposed to move. Can I have a const vector, something like that? Godot constant vector. Well, up. Let's press vector with constant size. I mean, it's an array. Data containers. STD array. Well, it's like compile time though. STD vector with reserve. I mean, technically, I guess. Okay. But yeah, tell me more. How long have you been on your current game? 3 AM, oh no. So... Can I... Wait, I just realized, instead of having those things, task collision, I can actually just directly get the pair. Because I also have the data inside. Right. And then I can loop over my pairs. Something like this. And then I just need oh, I don't even have... Oh no. I mean, I guess I might need pointers in this case. Yeah. Yeah. Okay. So let's say this is constant. Lifetime, I guess. After registration. Maybe. And the hash map is from a convex collider, like a convex shape, to the projection, to the projection range, to each axis. So technically something like projections, like convex shape projections. And you have the hash map. Oop. That is to an index, something like that. Looks good to me. So convex shape to projection range index, something like that. Okay. And then convex shape. I mean, the convex shape is supposed to have an array of vertices. What about, wait, constant? No, this is not the one that should be constant. This is the one. And convex shapes, it is a span. Maybe. Vertices. Technically, I could optimize the memory even more, but that's fine. I'm optimizing too much. I don't have anything. So technically, I have the algorithm ready. I need to cache and split the convex shapes. Convex shape projections. Let me think about this. By the way, I don't know how to code, but when I see code, it makes me go, yes, very cool. Yeah, hacker man. Yeah, I feel it. It's like in movies. Yeah, go. It's time to hack to the Steins Gate. By the way, I'm thirsty. Are you? I mean, not much. I mean, usually, basically, I guess I'm very, how would you call that? Split? I guess not anymore. Like I'm very split from my needs. Like sometimes I don't really know what my body wants. And you know, I guess that might be one of the reasons I'm fine with being awake at like 3 a.m. is because I don't really feel hunger, how do you call that? Hunger, sleep, and a thirst that much. I just still feel it a little, but yeah, I can manage pretty well, I would say. So instead, we're gonna have convex shapes there. But they're supposed to be like this. I mean, instead of looping through the colliders, the concave colliders, I guess I should create pairs and loop through the pairs instead. I think that's the smart thing to do. Or, I mean, ideally, I should even have a grid and have some broad phase with the grid, within the grid. But I'm not sure because I'm planning to have different spaces, and a grid assumes you have Euclidean worlds, and it's like a bit, you know. The only hard thing in C/C++ is leaking / adding additional libraries. Yeah, I would say that's very, yeah. I mean, there's in C++ 2020, or I think it's 20, you have modules, added modules. So you basically have this, and it's supposed to make it easier to add modules, basically. So I guess libraries, in a way. I think. Or maybe just to replace headers. Well, actually, no, I think it's... I'm not sure. I've never used them, and I've never seen anyone use them. But, well, it exists. Maybe one day, maybe in 20 years. I think it's supposed to make compilation faster because with includes it's basically a copy and paste of the header file, and it's like pretty big to parse and stuff. And yeah, if you have modules, it's supposed to make it faster to compile. But I'm not really sure about library use. But yeah. So we want the goal is to have pairs of objects. Maybe I can split them in chunks. Technically my chunks are all right. Chunks are a grid that I can use. And it's like a grid that can work in like multiple different, how would you call that? I don't know. In different referentials and like with different voxel types and that kind of stuff. So that can be a nice thing. But I have to think a lot about it. A and B is supposed to be good now, please. And let me. I'm gonna modify things. Create collider. This is gonna be create concave collider. Or do I want to assign it to a chunk too? If only. Yeah, let's not over optimize things. Chunk. It's just supposed to be a pointer. I don't really need this implementation. This is just the key. Kind of. Well, actually it depends, but yeah. So we have the grid thing. Create concave. Maybe? Or is it? I don't even know how I'm going to create my convex and concave polygons. Well, concave is pretty simple. It's just you take all the points and you know, put them. But I mean, actually convex is pretty simple. Never mind. Yeah, convex is fine. But I still need to assign them to like an object. I think. That is going to be a collision object, I don't know. Voxel collider. Okay. Okay, I mean, I guess it's fine. So maybe you have this. Like chunk in world. Like position in world, you could say. In Python, you just tell what you need and you're good. This vendor modules in C++ seems different. Yeah. It's definitely different. You know what? I'm going to make something. I'm going to change how things are. I'm just going to create a new function that's going to make create. That's going to be called create static collider, and it's going to change everything. Maybe not. So that means we don't need that. We need the axes because they should be constant. So a span? Like an array? I mean, I guess a span. Axes. So we have the position in the world for the grid. Kind of. Maybe I can store... Oh. I don't know. Never mind. I'm not sure. Anyways. So, we have the axes, and we should also have the convex polygons. So something like convex. Like this. Wait, a span of a span. Is it really the right thing to do? Nah. Nah, it's not. I want to collide. Well, I guess I want to move the vector. So I want the vertices. H2, vector 3, vertices. And I want this to be moved. So maybe I can have static collider arguments, I don't know. Or something like this. Vertices collider. Well, this is convex colliders. And I guess this is nice because that way I can also remove... Never mind, that sucks. Yeah, but this is alright. You can create this. And what I want from this is... I'm gonna pseudocode it. I'm gonna create convex. Yeah, I'm gonna have this. Convex shapes. Wait, convex shapes. So this is wait. Convex shape. Here we go. Then we have the convex shapes allocator. Convex shapes allocator. So something like this, maybe. With the convex shape. There we go. So what I want is I want to make it a pointer, because what about an index? No, because it has some value. I want it to be a pointer so we can have a hash map from the pointer to something else. And it should be like pretty lightweight, like pretty small, because it's just a span, right? So yeah. I think I need to get myself checked. What do you mean? Oh, are you like that thirsty that don't drink the water of your toilet? Okay. It's not clean. I've been inside my house all day. I mean, me too. Oh no. But yeah, I guess let's go. Yeah. W. No, it's L. It's a big L. What do you mean? I mean, I should go out a bit more. Like I'm starting to notice that, like, really my muscles just blah, blah, blah. Like last time I ran was fine, but the time before it was like very difficult. Even though like I'm not fat, so bro was home all day. They started streaming at 1:30 in the night. No, well, oh, lol. No, I started at like 11 p.m. because I have a day job that I finished at 10 p.m. and because I guess I did 10 hours at my full-time job, and then I called my dad, and then I started streaming. That's the full the full story. Bro was home. Well, no. New location. So we have the convex shape. Here we go. It's 3:30. You started 30 minutes ago, so it's 2 hours. No, it's because the stream got interrupted. Because in the middle of the stream, OBS stopped. Because I don't even know why. Like if you go on YouTube, I can tell you. It's like 4 hours. The stream is 4 hours long. So 4 hours long, since it's 3:30, it's like 11 and a half. Oh no, sad, yeah. But it didn't stop on YouTube. So that's nice. Well, I don't know if I should say that because Twitch, actually. But anyways, it's good. It's good. It's good. So basically we have the convex shape. Wait, what for? I mean... for this. Convex colliders. I allocate a new thing. Hello, Nightic. How are you? How are you? Nice to see you. That's me, by the way. Oh! Oh, never mind. Yeah, yo. Saroha, right? Saroha. Yeah, that makes sense. Saroha. Got it. Um, I mean, I guess what I want is I want to allocate this. So I said I was gonna do some how is it called? Some bullshit code, let's call it like that. But I'm actually starting to make some nice code, which is not really a problem, but you know. So maybe we have something like that. Do we? Const vec3 to... Huh? Oh! Oh, it's a span of span. I want a span of span. Wait, that sucks. Does it? Basically this, right? It feels like I'm going from a data-oriented thing to an object-oriented. I don't really like that, but then I have the collider. I'm going to... Well, I have the convex shapes. Wait. I can actually just have... Wait. I'm not sure about that. Yeah, that sucks a little. I mean, maybe an array of convex shapes would be fine. Yeah, maybe I just have to make things one by one. Okay, let's make things one by one. Well, this is still gonna stay. And I'm gonna have something like convex shape creates convex shape. And then maybe not delete. Do I want to delete? Not really. I'm not sure. Well, it's gonna be destructed like automatically. That's fine. So you have this, create, and I just allocate. Do I? Well, yeah, I guess I do. Something like this. Please! Voxel correct. This one. Here we go. And I guess I want an array. Well, a span. Okay, you know what? Let me do that. Let me have the return. And... I guess I'm gonna... Opa, get the vertices. Oh, no, because... Oh, yes. Wait. Yeah, it's supposed to be a span. It's good now? What do you mean it's good now? My username. Oh, yeah, it's good. Yeah, it's good. It's Sarun! Right, my username, yeah. It's a bit slow on YouTube. There's like some delay. Okay. So... The thing is, I want to store the vertices in the parent object. So it's like aligned in memory and all good. But the problem is that to make a convex shape, that means I can't just pass the data. Can I? I want to pack it as much as possible. So that's why I want to make the convex shape along the concave shape. But it's a bit difficult. Maybe I just need like, I was gonna say shape. A concave shape. Should I have a concave shape? Because a concave shape is just a collection of convex shapes. Oh no, it actually has the vertices too. Alright. It's dirty. And yeah, the collider might have like more things, more data. Maybe that's fine. So something like concave shape. Wait, vertices is a span? Oh, never mind. Yeah, there. Constant. Then we have convex shapes. I mean, yeah, that's basically this, right? Something like this. I guess it's fine. In C++. It's for C++ only. Like local vector span, I don't think it's in GDScript. But technically I can create them both. And set them up. I'm not sure. Yeah, I mean, if I expose them, I guess I'm gonna expose them. Like the user to create like those things is going to have to create the shapes, and that's gonna be good and all. Concave shape. Okay. So we're gonna have something concave too. Maybe. Maybe not. I mean, I guess, yeah. Because we want to free it in the end, right? So something like this. Convex shape, concave shape. We have the same there. This one is smaller, and that's fine. And this one is basically going to have a concave shape. And we're also going to have, what are we going to have? Axes, right? So axis data. And basically what we want now, what do we want? I don't know. So the collider is inside a chunk, for example. And where are we going to store the indices? The indices pre-computed things. I guess there we should have collision pair. I mean, it's pretty nice, but I also want something like... So I guess voxel collider is actually wrong. It should be like about the shapes. So this convex shape, or like actually it's going to be the concave shape. Maybe. So from this, we should have... well, actually it's a pair. It's a pair between... Okay, maybe I want a class actually for that. But a pair between the concave shape and axis data. Yeah, that name sucks. It's going to be instead something like referentials. Like referential, like a space, like I don't know. Yeah, space is fine, but referential is fine too. Yeah, referential is fine. I'm just gonna remove this. So we are going to have a list of axes. This is important. And we want to... So there's going to be a lot of hash maps, but that's fine with collisions, probably. So we want to pair concave with this, with the referential. And this is basically going to store the what? Wait, do I want that? Do I want a hash map? Because I could also make it part of a class. Referential. Let me think about it. Do I want this to be here? Maybe I have to think about the pairs first. Honnêtement, je me souviens plus quelle langue nous utilisons. Oh. Thanks for the follow, Pendor. Wait, I've seen you before, right? I feel like I know this name. Maybe not. Oh, it's you. I thought I was following. Yeah, that's what I thought. Yeah, yeah, me too. Thanks a lot for the follow, W follow. Yeah. Oh, I only have like three droplets. Okay, I have one left. Thanks for that. Let's go. W hydrator. Voxel collider pair. Yeah, that's... The name sucks. I'm gonna remove everything. And this is instead going to be something like I don't know. I'm gonna redeem something that I don't know what it does because it's in French. Oh, what is it? Oh, I mean, you're right. It's basically, you know, stand straight you know, like right, don't kill yourself. Thanks for that. I really needed it. So we can have a collision pair. Maybe not. Okay, maybe this was fine. It's probably the 1k one. So let's say we have this collision pairs map. Oh, actually, this is fine. Wait, not this one, this one. So we have concave shape to what language is this? I do not remember, but for a Minecraft game in Visual Studio, I imagine it's C++. Oh, yeah, it's C++. Yeah, how do you know? Okay, wait, it's your first time seeing the game, right? Because you've been here for the game jam, right? What if I redeem drink for 10 times? Oh no, no! I'm gonna drink like 1 droplet every time. But yeah, basically I'm making a donut Minecraft. Like, as you can see, this is like pretty funny. It looks like a galaxy, but green. Yeah, I can understand. And yeah, basically this is magic. This game is magic. It's pure magic. Like in so many ways, man. Basically, I'm remaking my renderer. I'm remaking my physics engine. I'm remaking so many things. It's almost a custom engine now. One day I'll make a game good enough that the C++ user will be like, cool game, which is a non-C++ indie game dev stream. Yeah. I mean, the game doesn't have to be in C++ to be cool. Like, look at Undertale. It's made in Game Makers, right? Yeah, I don't like Game Makers. I've never used it. It's not that I really don't like it. It's that I guess it has a reputation of being very simple. What languages do you use right now? Lua and GML. I don't know GML. I hate Lua. I don't know how people can code in Lua. And finish your conditions with like and if or something like that every time. I don't know about those, so I use GameMaker. Oh, you mean oh no, sorry about that. No, I mean I don't have anything about, well, I don't have anything against GameMaker, but you know, it's just I was just highlighting how you can make, you know, nice games no matter the engine. Like, it's up to you in the end, right? And I'm sure you can make it. The concave shape referential. Wait. So instead of doing a map, I can have it be contained. But I'm gonna have a hash map anyways, am I not? Actually, I can loop. Wait. Axes. Okay, so what about the... because there's a cross product too. And the cross product. Okay. So the cross product is gonna be about the pair. We have the pair data. You know what? Let's have something like convex shape. A. Then we have B. Then we have the referentials of each one. Do we? Wait a second. That feels wrong. That feels very wrong. No, that feels wrong. I have no clue what to do. Wait. I try to dip my toes in game making, but I can't make a move. Oh no. Undertale uses GML and Balatro uses Lua. Those are like the most popular games made with each of those. Oh, I didn't know that. I didn't know about Balatro. And I didn't know about the languages. This game maker, John Game Maker is the best tutorial guy, something. Okay. I haven't played, but busy doing HTML, CSS, and JavaScript, but very good. Just shit code, but singing songs and hope it works. Since Game Maker is adding smarter languages and 3D, I have no reason to move. Maybe. I don't know enough about it. But if you only learn... So basically, I've used a lot of different engines. And I think using a lot of different engines is good because you can see the strong points and the weak points of the engines you like. And if you don't like something in the engine you're making, if you don't like something in the engine you're using, then you can always take inspiration from other engines to add it to the engine you want. So I think that's like a nice reason to try out a bunch of different engines. But you know, I'm an engine programmer, so that kind of makes sense, right? That I can go that far. But maybe you don't want to spend as much time exploring different things and learning about deep, like low-level programming and that kind of stuff. And that would make sense. That's fine too. Because time is a resource, right? I music to a lot. I play guitar, mainly play. Ooh. Play for me. Ooh. Nice. Never of those games are good. Especially Tequila Shuffle. Oh. Too bad. One day, you'll make it to the top game on Steam. You'll make it to the next triple I, maybe? Is that indie games? Like the triple A for indie games? I don't remember. Wait, I meant names. Not... Oh, games. Oh, my bad. Yeah. Okay, got it. Yeah, I got it. I wasn't sure because you did say it was bands, right? But, oh, yeah, never of those games. Yeah, that's why I got confused. There are so many people. That makes me not wanna stop, but it's so late. Hopefully I don't start that early. Well. Okay. So. I'm gonna keep my things. I'm gonna keep my hash map, and this is gonna be fine. Okay, concave shape, referential cache, maybe? Wait, so you're French? Yeah, I am. How did you know? Is that my accent? No! I've been betrayed. Ach. I have no idea. Wait. Because it feels like it's not going to be optimized. People from my country really don't like. Okay, you're British, aren't you? But you're fine. I'm sorry for the hate. No, I that's why I fled. That's why I live in Japan now. Just kidding. Well, I do live in Japan though. But that's not the reason I moved. No, in Spanish, not. Everyone hates us. Good enough. I mean, I feel like with the World Cup, there's going to be some animosity. But, but yeah. Referential concave shape. So the problem is that, okay, I'm going to project my concave shapes to each axis of each, well, to each axis of the referential, but it's not going to be a lot. So I don't really like that. Wait, you said you live in Japan? Yeah, I do. That's why it's like 4 AM right now. Maybe that's why I can't focus much. Let me... Yeah, so I want to list... Okay, so what I want, ideally, is something like floats ranges. So it's local, well, so that it's contiguous in memory. And I guess what I want is it's like 4 AM in there. And as I said, and as I say that to show the time. Yeah. Yeah. Is it worth it? Should I just have a span? It feels like it's not really worth it. I'm not sure. I mean, allocation-wise... Oh, no, never mind, because vectors are right. If I have a local vector, it's still like an indirect... like, there's still a pointer. So if I have a span, it's like better. It should be better. I hope. But like, to remove... It's gonna be complicated to remove things. Ah! Okay, for now, we can have something. Like, I guess a span of floats. Well, no, I just said the span was not a good idea. Ah! What am I gonna do? But, okay, that's actually kind of complicated. You know what? I'm gonna sleep on it. I'm just gonna sleep on this and think a lot. But basically there are many... I'm probably going to make a diagram. Oh, I can't... Okay. I actually want to make the diagram right now. Let's go there. Let's do it. Here we go. So we're gonna go on Draw.io. I like this website. And I wonder if there are non-visual programming languages in not English, like Kurinto, Konnichiwa, Sekai, Ohio Sekai Kumori. Oh, good morning world. Long ass break, get dang it. Oh, you missed the most important part. So let's say we have concave shape. We have convex shape. We have the collider that has, actually let me make UML, something like this. The collider. We have the chunk. And it's basically a chunk, right? A grid position. Then we have a concave shape. And we have some other things like static or dynamic, that kind of stuff. Like static slash dynamic. Okay, is it good? Is it finished? Is it over? Yeah, and yeah, about programming languages. Do you know about P? It's not Prince. It's not Pierre. It's, I don't remember the name. I know. There is Rockstar that is pretty nice. There is Brainfuck. So this is a language that only has those characters, and Hello World is basically this. This is Hello World. Then you have Rockstar that has a whole website and documentation, and that is incredible. I love Rockstar. Rockstar is this language, and it's basically, oh, they have a non-line interpreter. That's incredible. But yeah, basically it's a language that prints Fizzbuzz. That's just regular JavaScript. What do you mean? This? This is a language. I mean, maybe the interpreter is made in JavaScript, but yeah, it's still good. I didn't have that before. And basically, you just write poems, and you know, it just works. The brain language. Oh, it's just JavaScript. Is it? Is it that? Is it that bad? Is JavaScript that bad? And there's another one that's called not Spiral, esoteric programming languages, and I should find the one I like. Well, I already like those, but it's like a very famous one. But now, be fun. Oh, Payet. You have those ones. This one is like Hello World. Shakespeare. Oh, you have lambda sky. But lambda, do you know about lambda calculus? I love lambda calculus. It's basically a mathematical representation of programming. And well, basically functional languages use this paradigm. And I don't like functional languages, but I love the math of this. And yeah, like for example, what is there, like a functional language? What functional language is there? I forgot. I never use those. Programming. Haskell. Wait. Yeah, Haskell, I guess. Let me show you. This is a functional language. And I don't understand what it is. Basically, you print this. This is the function, this is the value. So you call this, well, you replace factorial with this, which is recursive. And you have the base case. I don't know what it is. This is not, well, this is recursion. And I don't know recursion in functional languages. But it looks nice, maybe. But yeah, basically, there is no difference between a value and a function. So this is what's really nice about functional languages, mathematically wise. So you have this, you have the concave shape with convex shapes. Like, I guess it's an array. Or is it? Maybe it's a span. Maybe, is it? Not really, it can't be a span, that's the problem. Yeah, but if I have vectors for that, I mean, actually, I'm never going to use them. Never mind. Am I? Concave. So I guess I have the... Do I have the vertices? Maybe. Like local vector 3, vertices. Good enough. Then we can remove this. And convex is just going to be a span. So this is a span into the concave shape. So maybe I can cheat a little and do something like this to here. Like it's not owned, but kind of, yeah, it's owned by this. And what? Yeah, how should I handle cache? So I also have axes. So something like referential. Am I though? Collider. I mean, maybe. It can't be an index. I don't like it. Can I allocate each axis with the allocator? With the page allocator? What does it look like? Yeah, but it's gonna be very small if like the page finishes out of nowhere. Yeah, nah. But that's not supposed to be the data, so I shouldn't have to worry too much about those. So we have referential, normals, maybe? Actually, it's not even a referential. It's a shape normals, really. Shape badge, shape group, or like a normals group. Normals group, maybe? Something like that. So we have normals. That's going to be a vector. A span. A span is maybe better. Is it? No, it's not. Okay, this is going to be a vector. A local vector. I suppose. Yeah, because this is not supposed to be what's important. Well, what's important? I guess nothing is important, really. So you have this. You have a local, well, you have a normal group. For every convex shape. No. No, you have one for multiple concave shapes even. But it's gonna be convex. Huh? Something like this. I mean, I know that it's not the right arrow, but that's fine. I'm gonna put some comments. Where are they? I know they suck though. Wait, 2 seconds. Ooh. Yeah, I really should have gone to sleep. It's never too late, it's only 4 AM. But I really wanna do this! Normal group. Where are my comments? Where are my comments? I don't have any comment. What? That's a comment. The way I know it, but it sucks. Let's have this. No. Let's have this. It's basically going to be... Well, actually... So this is going to... We're going to have something here that is going to be a reference to a normals group. Right? And it's like not owning. This is a reference. And then we are also going to have the for each concave shape, okay? Or should it be here? I don't know. I don't know. I mean, I guess it's fine. No, it's not. Let's have the Voxel physics server. Inside we are gonna have a bunch of things probably good. So we're gonna have a map from maybe it makes sense to have this here actually. That way I don't have to unravel the map every time. Should I put that there? Have a reference there too. Or have a reference back and forth. Like the Aona basically. Anyways. I mean, I guess I do need this in the end. There. Do I? Yeah. Because I need to remove it somehow when I remove the shape, right? Maybe. Maybe not. Maybe not actually. It depends. And then I can map the... Oh, this is convex. This is convex. So it's a pair. So normals group. Normals. Like axis group maybe. And like axes. Is it? I guess. I have a lot of jumps and I don't like that, but I don't know what's like the fastest. For now, I'm just going to prevent computing more. Well, prevent storing more. Because I guess it's good memory-wise to have those pointers. Voxel physics server. So from one group to another group, maybe. Yeah, that would make sense. Okay, I think that's what I was missing. I want to pair from one group, well, from two groups into the new group, because it's like the cross product, right? And that's what a cross product is about in the end. It's like two inputs, one output. Cross products, axis, cross products. That's what it's about. Group. Okay. It shouldn't be costing that much. Especially if I allocate each axis group, like the allocator and stuff. Like, and I keep pointers there. Yeah, I guess it's like pointers, right? Of course. So something like that. So we basically have. Then if I look through the convex, yeah, I'm not sure about my broad phase still. I can loop. Maybe I should have this there. The normals. Like this. Whoa. What? Normals group. Maybe a pointer to a pointer is fine. I don't know. No. I mean, technically, I'm not gonna need concave shape if I have the normals group there. So that might be fine. Might be good. And then axis group. Well, we basically loop through the convex shapes. We have the axis group, and then we can get the cross product of everything. Let me just check this. Very simple, but I want to see clearly the operations. So yeah, it's basically all of this. So you have 1, 2, 3, 4, 5, 6. Yeah, it's like vectors. It's vectors. No, it's wait. Actually, no, they're not vectors. These are not vectors. So wait, what? Yeah, no. These ones are flats. Wait, it's actually not that big, but cross. Yeah, I guess the cross products themselves are fine, but then for each axis group, you have the projections, right? So maybe there, in convex shape, I can have axis group, and it can be something like a map from this to a cache to like a projection. So it's an array though. Should I put that in the concave shape? Like I did with the other things. Oh, do I want... Instead of it being owned by convex shape, maybe I want it to be owned by the axis group. Because what? Actually, never mind. A map there. I mean, it would be a vector. Technically... Okay, technically I guess I can make it a bit better. And have it be projections with a vector of floods. And is it? Well, okay, never mind. I guess it is better. And then we have a span. And axis to projections. Something like that. And everything there is allocated. Let me do something. Everything allocated with paste allocator for fixed pointers. Why is the text so... What the fuck? What is that? What is that? What the fuck? Where is it? That's so stupid. That's so broken. Let me just have this. Here we go. Okay. So concave shape shouldn't really be used in the end. And yeah, we do need the broad phase. I was thinking about the chunks, but it's a bit complicated. So I can pre-compute all of this. This is not a problem. So what about Basically, that's it. So that's gonna be it. Thanks a lot. Thanks a lot. Thanks a lot, people. I can't talk anymore. What can we check? I guess we might go... You know what? Let's have some fun. Donut SMP. Wait, what? Okay, I want to rate this guy. That seems to fit perfectly. This is what I want. And yeah, for the broad face, we're gonna have a grid. But I'm not sure about grid using chunks. I guess. Like most static objects should already have a chunk, so that should be like pretty useful. But for dynamic objects, it might be a bit complicated. Maybe I want to split static objects from dynamic ones. Like if it's static, for example, you only have a reference to one chunk, but if it's dynamic, to multiple chunks. Oh, I don't know actually. Yeah, I really don't know. Anyways, thanks a lot, people. It was fun. And see you tomorrow. Bye bye.